Hey, good morning, scholars. Larson here with some deep thoughts by Jack Handy. Many of you have had road trips during COVID to places up north and whatnot, and this is kind of in that theme. The memories of my family outings are still a source of strength to me. I remember we'd all pile into the car, I forget what kind of it was, and drive and drive. I'm not sure where we'd go, but I think there were some trees there. The smell of something was strong in the air as we played whatever sport we played. I remember a bigger guy we called Dad. We'd eat some stuff or not, and then I think we went home. I guess some things never leave you. Hey, what I hope doesn't leave you is what we're going to be talking about today. And for this unit, our learning target is recognizing that functions are just things that we call relations that map a member of the domain to a unique member in the range. And then in particular, that's the target for the unit. In particular today, we just want to practice ways to graph relations and functions. So here we go. We're going to talk about relations and functions. And a relationship is just when you do one of these four things. You either set up some ordered pairs, like this, and you just, create a group of ordered pairs, or you make a table and have an X and a Y value, or sometimes you can graph a series of points, or you do something called a mapping. So it's like a circle, and if I have 1 and 2 over here, they are mapped over to 1 is to 3 and 2 is to 4. And if I go backwards, I can graph those points up here and here, or I could put it in a table and say it's really 1 is mapped to 3, 2 is mapped to 4, and those are XY values. Or I could say, we have 1, 3, and 2, 4. Those are the ordered pairs. All of these are examples of relations and just different ways, and they might actually even be functions, but they're just different ways to express them. So when we talk about, I mentioned in the learning target for the unit something called the domain and range, and that's something that you want to be aware of. The domain are the values you put in first. They're the ones that you start out with, and we call them input values. And what results is when you put something in either a relation or a function, it kicks out a value, and that is the output values. So let's just think about that first one that I had in the slide right up above here. I've got these ordered pairs, 3, 2, negative 1, 0, 2, negative 1, negative 2, 1, and 0, 3. What I'd like you to do is, in your own mind, identify the domain. And then secondly, we want to represent it in some way, either using a graph or a mapping diagram. I'll let you do that. Why don't you pause? So this is what we actually intended, this is just kind of writing out that my X values, 3, negative 1, 2, negative 2, and 0, are in the domain. The Y values here are the range. They're the ones that the X values are mapped to. And if I was to take some care and graph them, that's what they would look like here. Or I could use these two ellipses and put the X values here and the Y values here. This is called the domain, and this is the range over here. So what we've talked about so far is just assigning an input value to an output value. We are given an X value, and we say it's assigned or mapped to this Y value, the domain and the range. Well, we can take that a step further, and beyond a relation is something called a function. And what is true in a function is that every value in the domain, every value in the input, is only paired with 1, exactly 1, not anymore. So, like, look at this diagram over here. You'll notice that -3 is only paired with 2. -1 is only paired with 3. 2 is only paired with -4. But you notice that 4 is also paired with -4. But the key here is that each value of x is paired with only one value of y. Now, compare that with this second example here in B. -2 is paired to 4, -4. 1 is paired to both -1 and 2. That is a deal breaker right there. It is not a function, because a function is defined as a relation that maps a value of the domain, or the x value, to a unique value in the range or the output. Okay, so then the last example here. -2 is only mapped to -4. Now you notice that -1 is also mapped to -4, but these two aren't mapped to anything else but -4. Actually, as you go down the list, all of them are mapped to -4. And each input here has only one output. There aren't doubles, triples, quadruples. So this is a function, this is not, and this was a function. Okay, sometimes we need kind of clear-cut ways to determine whether something is a function. And we have this thing called the vertical line test. And one of the best ways to figure out whether something is a function is you graph it. You make a table, you plot it on an XY coordinate system. And then you just use a vertical line test. As long as you draw a vertical line and it only intersects in one place, you get the point? Yep, I'm sure you do. Then if it only intersects in one place, it is a function. It's not just a relation or a relationship, it's a function. So remember that vertical line test. Hey, this is going to date me a ways, but one of the best players on the Timberwolves used to be Kevin Garnett. And if we were to get some data from probably NBA and graph some things, this thing over here is graphing Kevin Garnett's average points he got during each year he was on the Wolves. And he might have actually gone a little bit further and then come back. But these are from when he was 20 all the way up to 28. And you'll notice each year he seemed to improve and get just a little bit better. What I want you to notice over here is that we're not saying that he scored, 19 points and 23 points and 28. We're not saying that. He was only able to score one number per year in terms of an average point that he would score. Now, if we were to compare this relation, this is a relation and it's also a function, because when I do a vertical line test anywhere, I only intersect in one place in that point. Now, over here, these are all of the Timberwolves players at the same time that Kevin Garnett played. And some of them, in fact, I think Kevin Garnett is at age 28. He's represented here, the same number. But anyway, what we notice is that there was a number of players, at least two, at the age of 28 that had the average points of both. One guy had 9 points and Garnett had like 29 points. And because in this graph, when I draw lines almost all over the place, it's okay, except right here where I draw this vertical line test and I intersect 2 points. Because of that, this is just a relation. It is not a function. Because remember, every value in the range, so age in years, has to be assigned to a unique value in average points. So What we're going to do is we're going to review for a second. We have been talking about equations in two variables. That's what we talked about last week, and that you actually did a summative on Friday. Equations in two variables. They looked something like this. And what I'm going to suggest to you is that all of the x values that we have worked with and numbers that have represented, ordered pairs in an xy ordered pair, all of those x values have been the independent variable in that they're on their own. They don't depend at all on y. Actually, the only thing that depends in this scenario right here, y is the dependent variable because its value depends on what you assign x. If I assign x 1, put it in this equation, y is 11. It's dependent. It gets its value 11 based on what we start out with x. So I want you to be aware of the idea of independent versus dependent variables. And the other thing is every xy ordered pair, or every entry that I make in this table, when I plug in a value for x and I end up with 14 for the y value, or I plug in 7 for x and it kicks out 29, all of these ordered pairs are called solutions. And what they do is they form a graph of this y equals 3x plus 8. So what we're going to be doing is we're going to be graphing these things and kind of really reviewing what you did in previous years. But what I want to suggest is that you start, and by the way, we're going to start real basic and then we're going to get more sophisticated. But we start by just constructing a table of values. And you plot enough points so that you can get an idea of what the equation looks like. I often will do -2, 0, and +2. Or some other people just do -1, 0, and 1. And then they figure out what the values are for y. Some other people want to get a bigger picture and they'll go -10, 0, and 10. Just depends on what you decide, but you have to plot enough points to be able to recognize a pattern. And then connect the points with a line or a curve. That is the idea of graphing. So what I'd like you to do is consider this. This is not the same one that we had up here, 3x plus 8. It's a little bit different. But what I'll have you notice is that I have already kind of put this table on its side, and I chose values for 2, -1, and 0 for x. I chose -2, -1, and 0. And then what I did is I said, okay, if x is -2, then -3 times -2 minus 2 is what y equals. So -3 times -2 is a +6, minus 2 is 4. That's how I came up with this. And I did the exact same thing for y equals -3 times -1 minus 2. This ends up to be 3 minus 2 is 1. And then when I put in 0, y equals -3 times 0 minus 2. I end up with -2. So you'll see I got this table just like down here. And then when I graph these points, I plot them on an xy coordinate system. And remember, sometimes I insist that you always label your x and y value. That way you can't kind of graph pairs in the reverse. But you'll notice that if I have -2, -2, 4, it's this point up here. -1, 1 is this point here. And 0, -2 is that point there. Those are members of the domain that have been assigned a unique value of the range. And you notice anywhere I draw in this line, I only intersect in one place. So we would, in fact, call this a function. Okay, now here is something that is going to be just a little bit different. And you've probably seen it before, but I just want to make you aware that it's really just a way to write something differently and describe things differently. Instead of linear equations, we are going to be talking about the idea of a function. A unique member of the domain is assigned a unique member of the domain is assigned a unique member of the range. But we're going to have linear functions in this slope-intercept form. And it's just going to look like this. In other words, all I'm going to do is say the function f of x is mx plus b. And what I want you to recognize is this is not f times x. It is really pronounced f of x, or just f of x. Note that the function here, x, only has a power of 1. It's not a squared, cubed, anything like that. And that's what makes it linear. Every time you graph one of these, it will be a straight line, not a curve. Okay, so classify for me. Is the one in A, this f of x equals negative 2x cubed, by the way, to the third power, we call cubed, if you don't remember that. So x to the third is x cubed. So negative 2x cubed plus 5, is that linear or is this something else? And then why don't you say the same thing down here for g of x equals 12 minus 8x, or we could say g of x equals negative 8x plus 12. We could just flip them around and then it's in that form. Hopefully what you've said already, you go, Larson, you're not going to fool me. This is not linear. Anything squared, cubed, quadded to the fifth, sixth, seventh, anything like that is not linear. They are actually curves. This one down here is linear. It is a linear function. Okay, so now take it a step further. What we used to do is in the instructions, I used to say to you, even in your first summative that became a formative, I would give you, okay, find y when x equals 3. We would then just substitute in 3 wherever I see an x, and then we'd solve for what y equals. Well, now, instead of that, it doesn't seem like this is shorter, but it will in the long run. We're going to use just, instead of y equals 2x plus 1, we're going to say f of x equals 2x plus 1, and find f of 3. And when you do that, you go, okay, well, f of 3 equals 2 times 3 plus 1, so f of 3 equals 7. So another way to describe that is my independent variable is x and my dependent variable is f of x, or y. So nothing really complicated. It's just a change in the way we communicate and write. So I'd like you to do this one. Find f of 2. Hopefully what you were thinking about and have already started on is, this is no problem, Larson. I just find f of x, and in fact, to save time, I'm going to say f of 2 equals 12 minus 8 times 2, which is 12 minus 16, which is really negative 4. So f of 2 equals negative 4, and so if I was writing x and f of x, I'd say, well, the independent variable, or the member in the domain, is 2, and f of 2 is actually negative 4. So we'd write it like that. So notice that just one kind of I got that, Lars, I'm not going to make the mistake, is I'm not multiplying anything over here. All I'm doing is taking the x, and wherever I see the x in the other side of the equation, I put a 2. So I don't really do anything to the f of x. Or if I was doing g of x equals 7x plus 17, and I asked you to find g of 2, I'd go 7 times 2 plus 17. And then I'd say, well, g of 2 equals 14 plus 17 is 31. Something like that. That's another example. That's supposed to be a 1. Okay, you try it. I'll let you hit pause. Then you find out what f of 3 is, negative 3, and what L of 10 is, given those two functions. Okay, hopefully what you found is f of negative 3 equals 4 times negative 3 minus 1. And then we know that 4 times negative 3 is negative 12 minus 1 equals negative 13. Hopefully that's what you found. And then L of W, we're going to kind of take it up another notch and not just use F and G and X and Y, but we can use any letter in the alphabet. And when I'm trying to find L of W, in particular, I want L of 10, I just say, that's not a problem. Negative 2 times 10 plus 2 equals negative 2 times 10 is 2 plus 2. The whole thing equals 4. So in my world here, if I have W here and L of W over here, the way that I assign that in a table is this, or this, or going on a graph and going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up for putting a point there. So I can graph, I can solve, I can evaluate. So what we've been talking about is practicing different ways to graph relations and functions. Now your homework is going to be completing the worksheet in your packet, because you'll notice as now that we've started hybrid, I handed out a big packet for you to use so you can have the hard copy or you can find the electronic version in your Monday folder. One thing I want you to recognize is to make things a little cleaner, and so that I don't have to click on so many different links and different assignments, we're just going to hand in the homework at the end of the week all together, not daily. So you won't be handing in daily assignments anymore. And the last thing is, whenever you are asked to graph something, I make sure that you use graph paper. Thanks for listening.